We have here 5x over x plus 1 plus 6 over x minus 1 minus 10 over x squared minus 1. Well, we first want to, as we simplify this expression, we first want to find the LCD. And before we can find the LCD, we need to look at each denominator and see if it can be factored. If it cannot be factored, we're going to leave it as is. But if we can factor it, we need to factor that. We have here x plus 1, first fraction, its denominator. That can't be factored. We have x minus 1, we have the second fraction. That can't be factored. But we do have x squared minus 1. Now we can factor that. It's a perfect square binomial. We have two terms. We have a minus sign, and the first and the last terms are perfect squares. So this can be factored as two binomials, the product of two binomials. So this is x plus 1 times x minus 1. So let's go ahead and write that out. Okay, next we want to find the LCD. And the LCD, as we look at this, as we look at each fraction and its denominator, the LCD is x plus 1 times x minus 1. And what we're going to next is convert each fraction if possible. So I'm going to do this in stages here. We have 5x over x plus 1. That's our first fraction. And we'll put it all together at the end, but right now I want to just put it in parts so you see what needs to be converted. The next fraction we have 6 over x minus 1. And then the last fraction we have 10 over, well, the x squared minus 1. Let's go ahead and write the binomial form, the two binomials. We have x plus 1, x minus 1. So at this point, we ask ourselves, which fractions do we need to convert? Because we want to convert our fraction into having a denominator of x plus 1, x minus 1, the LCD. As you look at each fraction, the first two fractions we will have to convert, but the last fraction we do not have to because it has the LCD, the x plus 1, x minus 1. So what I want to do, we're going to leave some space between each fraction, but I want us to go ahead and write out the new LCD for the first two fractions. We're going to convert the first two. So my question to you is, let's look at 5x over x plus 1. Look at your denominator. What will we have to multiply? And we're going to, here again, start from the denominator. What will we have to multiply x plus 1 by to becoming the new LCD? Well, that is x minus 1. So now let's look at the numerator. We have here 5x times x minus 1. So this will be what we have here, the 5x over x minus 1 over x plus 1, x minus 1. That will be our new fraction. That's our equivalent fraction. Let's look at the middle fraction, 6 over x minus 1. Starting from the denominator, what must we multiply x minus 1 by to change it to its new denominator, the LCD? Well, we're going to multiply that by x plus 1. So our numerator, we have 6 times x plus 1. Okay, So now we're going to put all of this together over our new LCD. So let's do that. So our first fraction, this is what we have, 5x times x minus 1 over the LCD, plus the second fraction, 6 times x plus 1 over the LCD, minus, and we're keeping that third fraction the same because it originally had the least common denominator. So what do we know about fractions at this point now that you have a common denominator? The rule says bring your numerators together. We have 5x times x minus 1 plus 6 times x plus 1 minus 10 all over the common denominator, the LCD. So our LCD, again, as I repeated, x plus 1 over x minus 1. Now, our main focus at this point is to look at or focus on the numerator. So our numerator, what we're going to have to do, take the 5x, we're going to distribute twice. We have 5x times x, we have 5x squared, then we have 5x times minus 1, we have minus 5x. Then we're going to take the 6, we're going to distribute that twice. 6 times x, we have 6x, then 6 times 1, we have plus 6, then we have the minus 10. Add your like terms. We have 5x squared. Negative 5x plus 6x, we have x. And then 6 minus 10, we have minus 4 over the LCD. Now, once we are finished with the numerator over the common or the LCD for your denominator, we're almost there as far as answering the question. We want to see if we can factor the numerator. Okay, so we want to see if this numerator can be factored. So let's just focus on the numerator for a second. We have here 5x squared. Okay, 5x squared. Let's go ahead and write this out. Plus x minus 4. And we have factors of 5x squared, 1x times 5x. Factors of 4, we have 1 and 4, and we have 2 and 2. And which set of factors will we use for this? Okay, and we're going to use, of course, for the first term, 1x and 5x, and we're going to use 1 and 4. So as we factor this, our signs are different because the sign of the last term is negative. Our first term, we have here 1x and 5x, and then we have we want the middle term to be 1, so we're going to have a 1 here and a 4 in the last one. Now when we check our work, this is positive 5x, and then we have minus 4x. That would give us the middle term. So the numerator can be factored. Now let's go ahead and write the factored form of the numerator. We have x plus 1 times 5x minus 1, 5x minus 4 all over the LCD. And the LCD is x plus 1 over x minus 1. And then let's reduce the x plus 1's. And what do we have left? 5x minus 4 over x minus 1.